Okay, guys, so let's suppose we've got this circle. Now, that's a terrible circle. Looks like a hexagon.
What?
I want to teach you about something called not a cyclic, a cyclic quadrilateral. Not a psychic quadrilateral. Yeah, a cyclic quadrilateral. So what this is the following. Okay, so let's suppose we've got some points. We've got 4 points on the circle. So I'm just going to randomly select 4 positions. It can be anywhere. And now let's suppose that we take those 4 points on the circle and we join them with lines. Why, you say? Because you see, what we have now created is called a cyclic. Because the reason why it's called cyclic is because the 4 points are on the circle. A cycle is like it goes around, yeah. And quadrilateral because it's 4 sides. It's got 4 points. And there's some quite interesting facts about or theorems about a cyclic quadrilateral that you should know. So the first important theorem for a cyclic quadrilateral, and I'm just going to type this out, is that the opposite angles are supplementary. Now if you don't know what that means, it means it adds up to 180. So you see how that works, for example, is that this angle and this angle are considered to be opposite angles. So they are supplementary. So like, for example, if, let's say now this angle was, I don't know, 95. So now you have to ask yourself, to figure out this one, you have to ask what must you add to 95 to get 180. So that one is just going to be, I think it's 85. Now your reason that you would write would be opposite angles are supplementary. You could also say opposite angles of a cyclic quad are supplementary. That's another way of saying it. Okay, and so that's the first theorem that you should know. I don't know, what should we call that? Theorem 3 or theorem 4?
Is opposite angles are supplementary? Like, is that a universal rule, or is it just applying to cyclic quadrilaterals and some other?
It only applies to cyclic quadrilaterals. It has to have 4 points on the circle.
A square would also have the opposite angles as supplementary. 90 degrees, 90 degrees. All squares are.
Okay, so it's interesting what you say, that it works for a square as well, because the opposite angles of a square are 90, 90, which add up to 180. So does that mean a square can fit into a circle? Yes, it is possible to draw a circle around a square. So squares are cyclic, even though, so it doesn't have to have a circle around it to be cyclic. In fact, any 4-sided shape where the opposite angles add up to 180 will be cyclic. So even, no, not a parallelogram. Not a parallelogram. Okay, so that's your first theorem, and this is the second theorem. So let's imagine we take one of these sides. So for the sake of an argument, let's imagine we've got this side at the top here. And so you can see what I'm doing is I'm just taking a line, that's the top one. But let's say now we just extend it slightly. So you see what I'm doing is I'm moving along that line, but I'm just going further.
Now you have like an exterior.
In geometry, we say we produce, not like music, but we produce the line. And you see what that creates is this exterior angle. We call that an exterior angle because it's on the exterior. It's on the outside. And what happens, folks, is that exterior angle is basically going to be the same size as the furthest angle away from it on the inside, which is going to be there. Okay, so basically that angle is going to be the same size as this angle. So as an example, imagine this angle here was 92 degrees. Then it means this angle would also have to be 92 degrees. There's a very fancy way of saying that, though. So I'm just going to type it up here. So this theorem okay, so that theorem says the exterior angle is equal to the interior opposite angle. Now that's a fancy way of saying something really simple. Basically, the angle on the outside is equal to the furthest angle away from it on the inside. In your exam, you just have to write x angle of cyclic quad, just like that. Or you can say x angle of cyc quad theorem, or not theorem, theorem. That's a good enough reason. So if you write that, then you should get your marks.
Should, yeah, what should? Why is there a doubt here?
You should get your marks.
Why should? Why should?
You will get your marks.
Thank you.
I'll remember that.
Yeah.
Okay, now in fact you can do this for any side. You can do this for any side. So let me do this for another side. So let's imagine we take this. Now I'm taking a line, as you can see there. Hello, hello, hello. It's shorthand. Hello, hi. So anyway, that's awkward. So there is the line, there is the side, but you can actually just go a little bit further. Now that we say that we are producing the length. So if we do it like that, for example, then it means that this angle on the outside is going to be equal to the furthest angle away from it on the inside. So that should be, let's see, what's the furthest angle away from this one? Well, this one's the closest.
It's one on the far right.
It's opposite the closest one. So it should be there.
Yeah.
Okay. Yeah, so from this one, the furthest one away from it is going to be over there. You see, you take a look where the closest one is, and you just go across from the closest one. Okay, so those two angles are equal to each other. They're not supplementary, they're equal to each other. Oh, by the way, what is this one equal to now? Why? Yeah, because these angles are in a straight line, yeah. Okay. So what is the other blue one? 88. It's pretty easy, isn't it? Now, just notice something without us even realizing it, is that if I take this angle here and I take that angle, which is the opposite angle, do you notice that they are supplementary? You see there?
Yes.
92 plus 88 is 180.